This is problem 1 on practice exam 1 of module 1 in the book Problem Solving Guide for Mechanics and Thermodynamics. We have a person in a hot air balloon throwing a rock straight downward with an initial speed of 20 meters per second. That's a pretty good arm. It takes 3 seconds for the rock to splash into the water. Must be some water below. How high is the balloon? With what speed does the rock hit the water? We're going to ignore air friction. Let's start with a nice diagram. Here's a hot air balloon. Let's put some water there. Okay, some distance above, and you throw it down 20 meters per second. Hits the water 3 seconds later. How high is the balloon? With what speed does the rock hit the water? Now let's think. Let's not think, what equation can I use? Let's think about this problem and try to do it. Equations are for people who don't understand what's going on. If you don't understand, you're forced to plug numbers into equations. Let's think before we do that. What does gravity do? Gravity accelerates objects downward by 10 meters per second each second. After 1 second, the rock is going to be going 30 meters per second downward. After 2 seconds, 40 meters per second downward. After 3 seconds, 50 meters per second downward. Ooh, that's the answer to part B. We just answered part B. If it's in the air for 3 seconds, its speed is changing by 30 meters per second in the vertical direction. That's what gravity does. It started at 20 down. Gravity acted for 3 seconds. It's going to change the speed by 30 meters per second. It's got to be going 50 meters per second when it hits the water. So we got part B. Now let's think about part A. Starts off at 20 down, ends up at 50 down, changes linearly. How can we get the distance? Well, distance is rate times time. Speed times time, we need the average speed. We add them up and divide by 2. 20 plus 50 is 70, divided by 2 is 35. 35 is right in the middle of 20 and 50. We can use that as a representative speed, 35 meters per second for 3 seconds. That's 105 meters. There's an equation. Distance is average speed times time. So we have the answers. A is 105 meters, B is 50 meters per second, and we'll put it on the diagram. There's the 50 meters per second. We'll add the distance, and now we have the answers to that problem, but let's do more. Let's confirm that these equations give the right answer. V final squared equals V initial squared plus 2a sub y. V finals minus 50, V initials minus 20, accelerations minus 10, y minus 105. This also should work. 1/2 at squared plus V initial t. All of those are consistent with the results. And, figure out how far did it fall after 1 second. How high is it above the water at 2 seconds? Try not to be in a rush to move on to the next problem. The goal is not to finish as many problems as possible. The goal is understand fundamentally what is going on. Explore. If you get the same answer 2 different ways, it's a great way to develop problem-solving skills and a fundamental understanding of what's going on, which is the goal. That's problem 1.